turbine, that is a regeneration. Okay, regeneration is nothing but what here, it is just like a recovery of the heat, okay, from exhaust to, okay, inlet of the compressor. Let us see how the regeneration, okay, that will be improve the efficiency of the gas turbines. See, you can observe, here is a inlet of the compressor that will be absorbed by the compressor. Okay, now at the point 2 it get compressed. Okay, now you can observe at point 2 that will be passed to the what regenerator 2 to 5. Okay, now from 2 is a low temperature, 5 is a high temperature, because this is from point 4 exhaust come out, that is be passed to the what here exchanger, that will be leave the heat to the what point 2 and rise the heat to the at point 5. That means it will be recover the exhaust heat from the turbine exhaust, and 2 to 5 you are supplying the heat by the water regeneration. This method will be calling as a regeneration. Now later you are passing to the what combustion chamber. Now what is the advantage of the this one regeneration? You are going to reduce the what heat. Okay, you are going to reduce the heat addition in the combustion chamber, because some amount of the heat added by the regenerator. Okay, some amount of the heat added by the regenerator, automatically we can save the some of the fuel added into the combustion chamber. That will be improve the efficiency of the that is a regeneration. Okay, now at point 3, this is what exhaust come out from the combustion chamber, that will be passed to the turbine. Okay, turbine will be produce the work, and okay, exhaust come out from the 4. Okay, 4 is we are last we have seen, this is what intercooler and reheater. Exhaust you are leaving to the atmosphere. Now we are recovering the heat, because point 4 is a somewhat temperature. Exhaust means around, you can say, is a 60 degrees centigrade example. Okay, that will be transported to the what this heat exchanger. Okay, regeneration nothing but heat exchanger. Point 2 after compression, okay, it is just like a around 30 degrees centigrade. Now it will be come in contact. 2 is okay, enter into what here in direct contact 30 degrees centigrade, and point from the point 4, okay, it will be enter with what here, that is 60 degree, because and exhaust okay, absorb the this means leave the what heat to the what point 2, 2 will be increases to the what point 5. That's it, this method will be calling as a okay regeneration. Automatically you can get the what here, you can save the fuel. Okay, same we can draw the what I explained in the TS diagram, that I have explained in the TS diagram. See this one here. Now normal, that is one is what here your air that is atmospheric air condition. Okay, one is transport to the what compressor, and ideally it will be get compressed at point 2. Okay, now observe, this is a 2 to 5 how the temperature will be increased, that is okay, by using this is a regeneration. Just I told this 2 is a inlet of the water regenerator, and whatever exhaust come out from the point 4, okay, that will be absorbed by point 2, and 2 rises to the water 5. Okay, now you can see 4 is reduced now 6. Okay, once 2 is rises to what 5, 2 is rises to y, and automatically exhaust point 4 reduced to what 6. This means what is a heat reduced from point 4. Okay, that's a heat increases what here 2 to 5. This is just like as a heat balance. Heat neither we created nor it convert one form of energy into the another form. That means heat balance equation. Okay, 4 to 6 reduce whatever amount of heat reduce, same amount will be rises to the 2 to 5. 2 to 5. Now 5 at point 5. Okay, now that is you are passing to the what here, this is a combustion chamber. Okay, you are passing to the what combustion chamber. Now 5 to 3. Okay, 5 to 3 you are adding the heat. Okay, now you are going to add the amount of heat to the 5 to 3 here. Okay, that is you can observe now heat addition 2 to 3 you are going to adding the okay combustion chamber is a more. and 5 to 3 actual heat addition combustion means automatically you can save the water amount of fuel addition. That means regeneration efficiency will be, and this is by what simply exhaust goes out, that will be, you can take care of this one, you are recovering the heat. Okay, that is you are saving the fuel. Okay, and in the actual conditions you can see this one 1 to 2 dash. Okay, in the actual condition, what is the heat addition by the regeneration? There is a 2 dash to 5. Okay, now that is a heat addition by this okay, combustion chamber 5 to 3. Okay, 5 to 3, and next 3 to 4 dash is a actual expansion. Okay, 4 dash to 1 is a heat rejection. I think, I hope all of you understood that is this how heat regeneration process will be taking place, and by using TS diagram, and just to forget about 5. Okay, in this TS diagram, just forget about 5, and it is as good as, that is without regeneration. Now here also we can derive the this is what thermal efficiency what with regeneration, and thermal efficiency without regeneration. Okay, that is first with regeneration. For ideal case, we are writing, that is a writing ideal this with the network divided by heat supply. Okay, see Cp, what is the turbine work? Cp T3 minus T4, and compressor work for ideal case we are doing Cp T2 minus T1. But you need to take care of heat addition. We are doing ideal case, that is a regeneration. What about the actual heat addition in this one? T3 minus T5. T3 minus, don't take T3 minus T2. Why? This is what here we are, that is a, we are saved this fuel combustion fuel saving. That's what only heat addition from 5 to 3 only. That's what heat addition with regeneration T3 minus T5. Okay, understood? And this is multiplied by 100, you can get. So they may ask this actual case also, Wt minus Wc divided by heat supply. See, write the this one here, Cp actual case T3 minus T4 dash. Okay, there is a just we are replacing the what here ideal to actual. Okay, and similarly Cp T2 dash and T1, and that is a compressor work, and here Cp, okay, Cp, that is T3 minus T5. Okay, heat addition will be remain same. Okay, we cannot get the what here 5 dash here, there is a heat addition constant pressure, and that is without regeneration. For a first ideal case, last I explained this, forget about 5 is as good as 0.5, it is a normal cycle. That's what without regeneration. Sometime they may ask what is the efficiency without regeneration, and write this Wt minus Wc divided by heat supply. Okay, without regeneration, ideal case Cp T3 minus T4 minus Cp T2 minus T1 divided by Cp T3 minus T2. Okay, now you can observe without regeneration heat addition. Okay, T3 minus T2 in ideal case, but with regeneration we have taken T3 minus T5. That is the only difference. Okay, now you can see now in the without regeneration heat addition T3 minus T2. Okay, that I have written. In actual case, you are changing the what here only T4 dash and T2 dash, and there's a heat addition actual case. What you are writing T3 minus T2 dash on the actual case. This is, I hope all of you understood. That is the, all of you understood this one here. What do you mean by regeneration? Now one more important here, effectiveness. What do you mean by, see, let us we need to concentrate on the effectiveness of the water heat exchanger or regenerator, and how to calculate. Sometime okay, they may give the effectiveness of the regenerator here. See, you have a difference H pi minus H2. Okay, that is see that this one TS diagram, effectiveness is equal to that. So we are going to calculate calculate the effectiveness of a regenerator H pi minus H2, and that is whole divided by H4 minus H2. That is effectiveness means out of this what is the difference H4 minus H2. how much heat has to be added. Okay, from it will be shift from 2 to 5 means that is a you have a out of H4 minus H2, how much heat going to add, that is a H5 minus H2. This is in case of effectiveness in actual. Suppose you want to write in the case of actual, that is a H4 dash minus, you write this one denominator H4 dash minus 2 dash. Okay, now that is H5 minus 2 dash in the numerator, that I have written here. For ideal case effectiveness, this is a H5 minus H2, H4 minus, this ideal case you write Cp into temperature difference. Okay, Cp into temperature difference, and this is becomes in the form of temperature T5 minus T2 and T4 minus T2 for ideal case. And this actual case you can write T5 minus T2 dash, T4 dash minus T2 dash. This is very important. Effectiveness means 100% in the 100% efficiency. Sometime regenerator they are lying between this one 70 to 80%. Okay,